with that, we are checking to see if lines are parallel, perpendicular, or neither by examining their slopes. So in a minute, I'll give you the vocab that you need to fill out. That'll go on the paper that I passed out to you a minute ago. All right, it is about parallel and perpendicular lines. Then you're also going to be tested on writing linear equations that are parallel or perpendicular to a given line. So if I say like y equals 2x plus 1, give me a line that's perpendicular to it and goes through this point. All right, that's almost word for word a question that's on your test. So being able to do those things is what you'll be tested on. Again, you picked up the worksheet for it. You won't be able to do the whole thing today. We're just going to kind of touch on it and finish the lesson tomorrow. So here's the vocab that you need to copy down. So you can start copying it down and then I'll explain. But we have parallel lines are lines that have the same slope, but they never touch. So they are lines that have the same slope, therefore they will never touch. I'll give you some examples and elaborate more. Let's write it down first. Then we have perpendicular lines. Those are lines that meet at a 90-degree angle. I'm going to change this one, sorry, I know it's ugly. All right, and then we have the reciprocal is the flipped version of a fraction. So for example, if you have a whole number like 2, then the reciprocal would be 1/2. If you have, sorry, having technical difficulties. If you have a fraction like 3/5, the flip version of that, or the reciprocal, would be 5/3. So let me elaborate more on that. So parallel lines, like I said, they have the same slope, therefore they will never touch. So if I asked you, are these lines parallel? Then you need to be examining their slopes. So that means that they need to be in probably slope-intercept form, because that's where you can clearly see the slopes. And if they have the same slope, they will never touch. So for example, if I have like y equals 4x plus 2 and y equals 4x minus 7, all right, the y-intercepts don't really matter. We're just looking at the slope. If it's the same, then those lines are parallel. So they'll look something like this. This is just like a rough sketch. All right, but they will never intersect because they have the same slope. They're going up and down at the same rate. And like I said, the y-intercept doesn't really matter. But someone did bring up a good point earlier that if the y-intercepts are the same, do those lines touch? So if I change this to 4x plus 2 as well, aren't they like the same line? So those wouldn't be parallel lines, so those would be the same line, right? But they have the same slope, different y-intercepts, they're parallel. Questions about that? All right, perpendicular lines. I'm going to have you add something to this definition. but those are lines that meet at a 90-degree angle. And you'll see them a lot, especially second semester. And again, here's just a rough sketch. Two lines that intersect, and you might see like a little box there that notes that it's a 90-degree angle. And just because they intersect doesn't mean it's at a 90-degree angle. You can tell also by examining the slopes. So that's why I'm going to have you add something to this definition. So the slopes of perpendicular lines are negative reciprocals. All right, the slopes of perpendicular lines are negative reciprocals. All right, so that could be like if I have y equals 1/2 x plus 3. A line perpendicular to that line would be y equals -2x, and the y-intercept doesn't really matter. We could say +1. All right, so look at the slopes. If I flip the fraction of 1/2, is it 2? Yes, because it would be 2/1, which is just 2. And then if I make it negative, does it make it a -2? Yes, so that's why it's a negative reciprocal of each other. And then I can even work backwards from that too. 1/2 is a negative reciprocal of -2. Because again, you flip it and change the sign. All right, so that's what we mean by negative reciprocal. So down here, just reminding you what a reciprocal is. It's the flip version of a fraction. So reciprocal of 2 is 1/2. And then if I gave you the reciprocal of 3/5, or I asked you for the reciprocal of 3/5, what would you tell me? 5/3. All right, so just make sure, just because it's a whole number doesn't mean it doesn't have a reciprocal. All right, write it as a fraction and then flip it. Questions about that? All right, I'm going to switch the slides here. We're actually going to pull up Desmos just to kind of show you. All right, so Desmos is a great tool. You can use it to double check a lot of the stuff that we are doing in class. So I'm going to pull that up here and we're just going to kind of play around with it. So sorry, I'm going to switch the slides. All right, so here's Desmos, and I already put in some random equations, right? I see that these two lines intersect each other. The only way I can tell for sure if they're perpendicular or parallel is to look at the slopes. Visually, I can probably tell that it's not parallel, right? Because parallel lines never touch. So it's either perpendicular or neither. So let's look at what we put in for the slopes. The slope of the first one is 3. And the slope of the second one is -1/3. So if I flip 3/1, it does become 1/3. And then if I switch the sign, it becomes a -1/3. So does that mean that these two lines are perpendicular? Yes. All right, if I changed it even by a little bit, let's say I made it -2/3, or even just like a +1/3, I'll show you that in a second. It might look perpendicular, but it's not, because if I really look closely at these angles, this is more obtuse, it's not a perfect 90-degree angle, right? And that doesn't make sense. If I flip 3/1, I do not get 2/3. So that I know those aren't perpendicular. Questions so far? All right, then if I have to compare it to like a different line, let's say it's y equals 3x minus 3. All right, they look parallel, don't they? To tell for sure, look at your slopes. So look at your numbers in front of the x. Parallel lines, what is their slope? Is it the same? Is it different? It's the same. All right, so even if I change this slope by a little bit, let's say I make it 3.5, right? It looks parallel, maybe like right here. When I zoom out, they do intersect eventually. So it has to be like the exact same slope. Questions about that? All right, and then what someone said earlier, like I said, the y-intercept doesn't matter. But if it's the same, you got a line over each other. So that's like not a parallel line. It's exactly the same. Questions? All right, so if you were still writing, here's the rest of that vocab. Just wrap it up real quick. The instructions that you can put like at the top of all the boxes is to write the equation in slope-intercept form. But I'm just gonna put write equation in y equals mx plus b. So these are the instructions that you can write at the top, because it's going to be the same instructions for the teacher example, the class example, and the student example. We're going to write the equation in y equals mx plus b. For the teacher example, I'll highlight what you should write. That way you're not spending your whole time writing like a paragraph. All right, right passes through the point 8, 9. And parallel to y equals 3/4 x minus 2. All right, we're going to overall write an equation in slope-intercept form, but it must pass through that point and be parallel to that line. So if it needs to be parallel, what does that indicate? Like, what do I know then about my new line? It's going to have the same slope. Good. So by definition, if it's parallel, they have the same slope. So what's going to be my slope in my new equation? 3/4. Now, if we don't know about the y-intercept, and no, I cannot just make one up, all right, because it has to pass through this point. So in order to do that, think back to like lesson 2.1. Where can I plug these in? The 8 is x and the 9 is y. So when I'm creating my new line, we want it in this form. We know that the m is going to be 3/4 because they're parallel. And since it also has to go through this point, I can plug it in. What's my y value? What's my x value? And then it's plus b. So you have to solve for b. You cannot just make up a b. All right, if it says it has to go through this specific point, then you cannot just pick a random point for b. So now start simplifying. What's 3/4 times 8? You can use a calculator, or you can do it by hand. What's 3 times 8? So one part at a time, what's 3 times 8? And then 4 times 1. And then 24 divided by 4 is good. So 6 plus b equal to 9. Get the 6 or get the b by itself. How do I get rid of the 6? Subtract it from each side, and 9 minus 6 is, and then we do get the b by itself. So now that we have our b and we have our slope, throw it all together. The line that is my final answer is y equals 3/4 x plus 3. All right, any questions? Oops, I didn't need that. I'm gonna highlight it. All right, so that's the final answer in slope intercept form. Good. All right, let's do the class example, and this time we'll go a little faster. So class example. All you have to write is what I'm gonna highlight, and the fact, and what you're gonna write is passes through the point -3, 5, and is parallel to y equals -2/3 x. All right, again, this is parallel. So what does that mean about the slope? So my new line should have a slope that is the same as the given line. So what should my slope be? -2/3. The b is a little more tricky to figure out because it doesn't just tell me. So I have to plug it into y equals mx plus b. Again, we know that m should be -2/3. And we're solving for b. What do I plug in for x and y? -3 and 5. So what's my y value? 5, good. Don't put -3. I see kids do that all the time. And then my x value is -3. All right, just because it's a fraction, don't let that intimidate you. You can use Desmos. Just remember to put the fraction in parentheses. So -2/3 times -3, what do you get? I think I got a +2. Does that sound right? Yes. Okay. Did someone check it on their calculator? I did. Okay, great. So it should be 2. So 2 plus b equal to 5. Get the b by itself. How do I get the b by itself? So subtract 2 on each side, and b equals 3. All right. Put it all together. The equation is -2/3 x plus 3. Hope you guys have that written down. All right. Questions?